This video is going to show you how to complete the problems on your geometry study guide. So number one, you'll notice that you cannot use a calculator on this problem. And I wrote that on there because on the test, the problems similar to these three problems don't allow you to use a calculator. So I just wanted to alert you to know that you can't use a calculator on these problems, okay? So anyway, right here we have, it looks like a rectangular prism. It might be a cube, but I'm not sure because I don't know the dimensions of it. But it says select all figures that can be formed by a horizontal slice parallel to the base of the cube. Okay? So right here I have just a manipulative. It's a cube. Oh, so it does tell me it's a cube. Anyhow, here's the cube, and we need to do a horizontal slice that's parallel to the base of the cube. Well, here's the base of the cube, and if something is parallel to it, it means it's never ever going to cross. So right here I have just a plastic knife, and we're just going to take it and slice it right there, just parallel to the base, okay? So if I slice that parallel to the base, that cross section would look something like this. And what shape do you see in the cross section? You should see a square. You should not see a trapezoid. You should also see a quadrilateral, because isn't a square a type of quadrilateral? And you don't see a line segment, okay? Because it is going to be a flat plane. All right, number two. Again, no calculator on this problem. And we have a cylinder. And it says select the figure that can be formed by a vertical slice parallel to the base of the cylinder. Okay? So we want to do, again, a slice parallel to the base of the cylinder. Right here is the base. So a slice parallel would just be kind of going right there, but be through it, or even right there. So if I just did that, you would see that we would have a circle as the cross section. That would happen. So it's not a square, it's not a trapezoid, it's not a rectangle, it is a circle. Okay, the next figure it looks like it's a square pyramid, or maybe a rectangular pyramid. I'm not quite sure because I don't know the dimensions of the base. But anyway, it says select the figure that can be formed by a horizontal slice parallel to the base of the pyramid. So right there is the pyramid, and I'm going to go ahead and take a slice parallel to that base. So there's the base, so we're just going to slice it, or slice it up there, wherever. And when we do that, the cross section we have, the shape that it forms is a square, or it could be a rectangle, depending on the dimensions, okay? So, we have square, trapezoid, rectangle, or circle. So, since it says that select the figure that can be formed, well, those could be formed. It could be a square, could be a rectangle. And to be more specific, we would need to know the dimensions to see if it was a square or rectangle. But since that's not given, your best two answer choices are square and rectangle. Okay, the next problem. It also says no calculator on this problem, so just know when you see this on an assessment, a calculator will not be able to be used during this assessment, so it won't be, or during that question on the assessment, so it will not be in the top corner of your screen. So looking at this, it says based on the diagram, determine whether the statement is true or false. So before even kind of looking at this stuff, I'm just going to go ahead and examine the figure. See right here, this is a line, J-A-M. There's another line right there. They seem to, they cross right here. And this angle right here is 130 degrees. I don't know any of the other angle measurements. But it says we got to determine if this is true or false. Angle J-A-N, so let me go ahead and find that. J-A-N, so this angle right here is equal to K-A-L plus angle L-A-M. So let me find K-A-L, it's right there, plus angle L-A-M, so that right there, okay? So it's saying that this measurement is equal to this measurement right here of those two adjacent angles added together. Well, I know that they will be congruent only if they're vertical to each other. So here's how to check to see if they're vertical to each other. You're just going to trace straight through and see if it goes straight. Okay, so far it matches up with that. Then the other part of angle JAN. Let's trace this line that helps form it. Oh, look, it's matching, matching, so that is true. This angle is equal to this angle. You know, these two angles added together. Okay, the next one. Angle JAN plus angle NAM should equal 180 degrees. So we investigate JAN. So that's this guy right here again. Plus NAM right here. That should equal 180 degrees. So when I'm looking at them, I see that there's a semicircle formed by their arcs. When I join their arcs, I see that there's a straight line right here. So therefore, yeah, those two added together, you know, they're going to equal 180 degrees, and they're supplementary. They're angles on a line, okay? They're angles on a line. Angles on a line add up to 180 degrees. Okay, now it's saying angle JAN is 80 degrees. Well, wasn't this JAN? JAN. So if this was 80 plus 130, does that equal 180 degrees? Well, no, it's more than 180 degrees. So therefore, that's going to be a false statement. Problem number 5, it says no calculator. So based on the diagram, determine whether the statement is true or false. So before looking at that, I'm just going to get more familiar with this. I see that a 90-degree angle is formed right here. So KNI or INK, that's 90 degrees. And since that's 90 degrees, that would make this angle right here plus this angle here, they're complementary because they would add up together and have a sum of 90 degrees. I think from here, let's go ahead and read through our options for true to select true or false. Angle KNJ, so this angle right here, is equal to angle MNL. MNL. Okay, so to determine if those are congruent or equal to each other, I need to figure out if they're vertical to each other. So let's see if these two are vertical to each other. So I'm going to go ahead and do the trace thingy. Okay, so that I went straight there. Okay. And then this one, oh, see how I had to do a little bend right there? Those are not equal to each other. They're not congruent. So since this says that they're equal to each other, they're not going to be. That's false. Okay. And then it says angle KNJ. We're talking about that same angle. Plus angle JNL. So this angle right here. Oh wait, no. Plus angle JNL. So this whole angle right here. KNJ plus JNL. So they're saying this whole thing right there is going to equal 90 degrees. Well, unfortunately that's not true, simply because there is no box right there to indicate that that relationship is 90 degrees. Okay, so that's also false. Alright, the next part says angle JNL. So I've already traced it. I just ended up tracing it in blue. JNL is right here. Is equal to angle LNM. LNM. So this one right here. And I mean, this is one you can kind of eyeball, and you should know that they're not equal to each other. Another reason I know that they're not equal to each other is because I know that they're each not 90 degrees. If this was 90 and this was 90, that would equal 180 degrees, and I see that they'd be supplementary. So for them to be congruent and also be supplementary, each one would have to be 90 degrees. Another reason I know that they're not going to be congruent to each other is that they're not vertical to each other. See how they're adjacent and they're just chilling right next to each other? That's not going to mean that they're equal to each other. Okay, so this is another one where we're going to mark false. Alright, again, no calculators on this problem. You'll see right here that we have angles at a point. And it says, based on the diagram, determine whether the statement is true or false. All angles add to 360 degrees. Well, this angle plus this angle plus this plus this plus this. Since our angles at a point, that is true. They're going to have a sum of 360 degrees. Okay, angle AOE is 56 degrees. AOE. So they're saying this right here is 56 degrees. You can add them all together and subtract it from 360, or you can go start off with 360 degrees and subtract each one. And I think that's kind of faster. So do whatever works best for you. So I know that they'll all have a sum of 360 degrees. I'm going to subtract this one because we know it, and that's 61. Then I'm going to subtract this one because we know it. It's labeled 73 degrees. Equals. And then I'm going to subtract 86 degrees. And equals. And I'm going to subtract now 84 degrees. So that leaves that this angle measurement right here is 56 degrees. So I'm just going to label that just so I have a visual. And it says angle AOE is 56 degrees, so that's definitely true. Okay, true or false? There are vertical angles. So for something to be vertical, it's got to be directly across from each other and not be adjacent. They can't be right next to each other. They have to be across from each other. And also when you do when you trace the segments or lines that form an angle, it should match up with the one directly across from it. So I'm just going to go ahead and check. So does this BOA or AOB, same thing, have a vertical angle to it? Oh no, because it had to bend. How about to here? Nope, it had to bend. Okay, let's try this one. DOE, let's trace. Nope, it had to bend. Here, trace. Oh, this one can that one go straight? Oh, that does not work because although these kind of match up, they're adjacent to each other, they're right next to each other, so they're totally not vertical. Okay, let's see this one. This one, oh, had to bend. Yeah, this isn't, there's none that are vertical to each other, so false. Okay, number 7. It looks like we are allowed to use a calculator on it, so you can use one if you want, but it says enter the scale factor applied to figure A to produce figure B. So since it goes from here to here, I'm going to say that this one's the old one and this one's the new one. So this is the original. And this right here is the new one. Okay, and I'm just going to go ahead and write down the numbers that I see corresponding to the original and the new. So right here it looks like the original one, which was labeled as A, has a diameter, because diameter is from here to here, of 5 units. Whereas this new one, it's got a diameter of 10 units. Okay, so to go ahead and find the unit rate, also known as the scale factor in geometry, you just got to figure out how did we go from the original to the new. Well, to find scale factor, you got to go y divided by x. Okay, so that y column, this one right here, that 10, divided by this 5 right here. Okay, it's y divided by x, which this column's x, this one's y. 10 divided by 5. Well, 10 divided by 5 is 2, or 2 over 1, same thing. Okay, so our scale factor is 2. Okay, we always multiply by the scale factor. Multiply the original by the scale factor to get the new one, okay? Number 8. Enter the scale factor applied to figure A to produce figure B. And this one is a little bit tricky because look at this. They labeled this one as B and this one as A. So you're starting with A and producing B. So look here, you start out with A, which was larger, and you produced B, okay? What do you know about scale factors when it started out big and got smaller? Is it going to be bigger than 1 or smaller than 1? Let's look at the previous example. It went from small to big. And look, the scale factor is bigger than 1. Here it's going to go from big to small. So the scale factor should be smaller than 1. Okay? So I'm going to go ahead and set up the same way as I did the previous problem. I'm abbreviating original with a rig, I guess. And new. You should know that the first column's x, this one's y. And the original measurement was 3. It's a 3 by 3. So you can just write 3 just one time since it's the same number. If they were two different numbers, then write down both of the numbers right there, okay? And since this side corresponds to this side, and that's 1, okay? So the same way to find that unit rate, also known as scale factor in geometry, you got to go y divided by x. So the y value divided by the x value, the y value is 1. The x value is 3. So I could go 1 divided by 3 and get 0.33333 forever, but whenever you have like a repeating decimal like that, and you're finding the scale factor, it's the very best idea to keep it as a fraction, okay? So 1/3 is the scale factor. Okay? So when you have an image that starts out big and gets smaller, you should expect that your scale factor will be a number smaller than 1, like 1/3, If your figure goes from small to big, you should expect that your scale factor is more than 1. And if for some reason you have the same exact size shape, then your scale factor is 1. Okay, it didn't change. Because you'll see we multiplied 3 by 1/3 to get 1. 3 times 1 is 3. 1 times 3 is 3. 3 divided by 3 is 1. So you see how we did multiply by that scale factor to get the new image? All right, your next example. I want you to think about it. Enter the scale factor applied to figure A to produce figure B. So we're going from small to big. Think right now, when you start off small and you get bigger, is your scale factor bigger than 1 or smaller than 1? Well, it would be larger than 1, okay? So what we got going on right here is I'm going to start with our original, so it was A, and then our new one. Okay, the original, and you want them to have corresponding sides. I don't know this dimension right there, so I can't really go off that. And I don't know this dimension right here, but I know this one, so that's not going to work. But I'm given these two dimensions. And I'm going to assume that they are similar triangles simply because they're telling us to find the scale factor. So if something's got a scale factor, it's got to be proportional, okay? So right here, in the original, it was 6 units. And right here in this new one, since these two are corresponding, the 6 goes with the 9 right there, okay? So we got to go ahead and find that unit rate, you know, also known as the scale factor in geometry. So we go y divided by x. Y is 9. X is 6. So I can go 9 divided by 6. Let's see, if that's a repeating decimal, then we would just keep it like as a simplified fraction. Oh, it's 1.5. Do you see that? So our scale factor is 1.5, which makes sense. It's the number bigger than 1. Started out small and then got bigger, okay? Okay, and just to show you, multiplied that x by 1 5/10, or 1.5. 6 times 1.5 is 9. 6 times 1 1/2 is 9. That does work, okay? Number 10 says a triangle has a 30-degree angle, a 45 5/10 degree angle, and a side of 12 feet in length. Select true or false for each statement about this type of triangle. So before I really get into that, I'm just going to draw myself a sketch so I can get a visual, okay? So I know it's a triangle, so I know there's going to be 3 sides, and just so you know, this is probably not going to be drawn to scale because I'm just going to draw just a random triangle, and I'm going to fill it in with the values that they give me, okay? So if you actually take a protractor to it and say, oh, I'm going to see if that's really 30 degrees, it's not because I just sketched it. So I'm just going to go, there's a triangle. Pretend that the sides are perfectly straight, okay? And they're not, and that, yeah, this is not very accurate. Again, I apologize. So it's got 30-degree angle, so we're just going to say, yeah, you're 30 degrees. 45.5 degree angle, okay, we're just going to say you're 45.5. Okay, and it's got a side length of 12 feet in length. I don't know, you could be 12 feet. You from there to there, okay? Doesn't matter. Okay, so using that visual, it's going to help me answer these questions. And by the way, no calculator on this problem. So the triangle must be an obtuse angle. Well, the definition of an obtuse angle is it's going to have an angle that's greater than 90 degrees. Right here, it's not greater than 90 degrees, and right here, it's not greater than 90 degrees. So I gotta see, hey, is this one greater than 90 degrees? That's where you're gonna pull back your knowledge. You need to know that every single triangle in the world has these inside angles. When you add them together, will have a sum of 180 degrees. Since I don't know this one, I need to figure it out. If it's more than 90 degrees, then yeah, heck yeah, it's gonna be obtuse, okay? And it's gonna be true. If it's not more than 90 degrees, then that's gonna be false, because then it wouldn't be obtuse. So what you could do is you could start with 180 degrees and subtract 30 plus 45 5/10. And I can't use the calculator on here, so it's going to be some writing. 45 5/10 is plus 30 is going to be 75 5/10. Okay? So when you subtract that out, you should get 104.5 degrees. So this unknown angle right there labeled with the question mark is 104 5/10 degrees. 104.5, okay? Degrees. And therefore, that would make it an obtuse triangle because there's an angle in there that's greater than 90 degrees. When you look at it, my picture again is not very accurate, okay? So this is a true statement. It says a triangle must be an acute triangle. Well, for it to be an acute triangle, all those degree measurements have to be less than 90. And since we have this one right there, that's 104 and 5/10 degrees, this is not an acute triangle, so that's a false statement. The triangle must contain another angle that is 105.5 degrees. That's not 105.5 degrees, that's 104.5, okay? So that's another false statement. Number 11, you'll see that there is also no calculator available on this problem, which makes sense because all three of these are examples of one of the problems on your assessment. So if you couldn't use a calculator on this problem, you can't use a calculator on these problems, okay? So a triangle has two 45-degree angles and a side length of 6 feet. So I'm going to draw a triangle. And we're going to say, hey, you're 45 degrees and you're 45 degrees, okay? And I can tell you right now this is not going to be drawn to scale for sure, okay? And it's got a side length of 6 feet. I don't know, let's make this one 6 feet. Okay, it doesn't specify. Select true or false for each statement about this type of triangle. The other angle is 90 degrees. Well, judging from my picture, it does not look 90 degrees, but it could equal 90 degrees, okay? Because when I add this, plus this, plus this, it's got to equal 180 degrees, because all the inside angles, also known as interior angles of any triangle, have a sum of 180 degrees. So what I'm going to do is I am going to go, 45 plus 45 degrees is 90. And I need to go 180 degrees minus 90. I got the 90 from going 45 plus 45 to get 90. 180 minus 90 is 90 degrees, leaving that this one has to be 90 degrees. Does it look like it from my silly little picture? No. It should look more like this. So this is 90 degrees, this is 45 degrees, and this is 45 degrees. This looks more accurate. When I first drew this, I didn't know any of the details really, so I just kind of started filling stuff in. So you'll see right here how this would be what the triangle would look like. And this is 45, 45, 90. When you add 45 plus 45 plus 90, you get 180 degrees, which is the sum of all the interior angles of any triangle. So therefore, that other angle is totally 90 degrees. This is an obtuse triangle. So looking at it, nope, it's not an obtuse triangle because it's a right triangle. It's got a 90-degree angle in it. So that right there is false. It says this is a right triangle. That is true. Okay, the next question says a triangle has a 100-degree angle and a side length of 18 centimeters. Select true or false for each statement. And if I haven't already corrected this, please fix that. It should say B instead of by, just a typo. Okay? All right, so I'm just going to go ahead and try to sketch. It's a 100-degree angle, so that's going to be bigger than 90 degrees. So pretend that's 100 degrees, okay? Okay, and connect it so it looks like a triangle. I hope you're better at this than me. Okay, and it says it's got a side length of 18 centimeters. I don't know which one's 18 centimeters. Let's make this one 18 centimeters. Okay? Select true or false for each statement. The triangle must be an acute triangle. It's not because there's a degree measurement that's greater than 90 degrees, which is 100-degree angle. So that's a false statement. Okay, the triangle must be an obtuse triangle. I would agree with that because this, simply by telling us that this is a 100-degree angle, that is more than 90 degrees, so that's true. It says the other two angles add up to 180 degrees. So they're saying that this angle plus this angle should equal 180 degrees. That's incorrect because all three of the angles, when you add them together, should equal 180 degrees, not just two of those. So that's a false statement, okay? 13 says a scale drawing of a cafeteria is 4 inches by 5 inches. The scale factor is 1 inch equals 4 feet. What's the actual area of the cafeteria? So actual area. So I'm going to go ahead and just draw just a quick little sketch to try to represent the situation. So I'm going to say, hey, you're the scale drawing. And I'm going to pretend that this is 4 inches, and it's not drawn to scale, obviously, by 5 inches. And it's saying that the scale factor is 1 inch is equal to 4 feet. So, well, there's 4 inches right here. 1, 2, 3, 4. And each one of those is, in real life, 4 feet. So you're right here, 4 feet in real life, you're 4 feet in real life, you're 4 feet in real life, you're 4 feet in real life, okay? So this length right here is 4 feet plus 4 feet plus 4 feet plus 4 feet, which makes that, in real life, 16 feet, okay? So is there a faster way, instead of just drawing all the little notches right there, like I'd have to draw 5 little sections and show 4 feet in each of them? Is there a faster way to come up with this length right here? Yes. And your hint right here is your scale factor is 1 inch equals 4 feet. So you're taking these inches and you're going to multiply them by your scale factor, okay, for each one of the sides. So 4 times 4 is 16 feet. 5 times 4 is 20 feet. Okay? We're not done. Because, yeah, you found the dimensions of it, but the question's asking about the actual area of this cafeteria. So this is the real-life cafeteria. What's the area of it? And it is a rectangle. So to find the area of a rectangle, you need to go length times width, okay? So to find the area, you go length times width. So we're going to go with 16 multiplied by 20. And when you go 16 multiplied by 20, you should get 320 feet squared, because we're finding the area, okay? Area is labeled in square units, or units squared. 14. A scale drawing of a bedroom is 2 inches by 3 inches. Not drawn to scale, by the way. 1 inch equals 5 feet. That's the scale factor. What's the actual area of the bedroom? So, I'm going to divide this up right here. So in real life, 1 inch on this little scale diagram is equal to 5 feet. So there's 5 feet here, 5 feet here, okay? And if I divided this up into thirds, 5 feet here, 5 feet this little section, 5 feet this little section. So the actual dimensions of the real life bedroom is, let's see, this would be 10 feet. And then from here to here would be 15 feet. Okay, that's not our answer though, because you need to find the area. You know how many squares are right there. So this is 15 feet, this is 10 feet. So when I go 15 multiplied by 10, because it's a rectangle, you got to go length times width. That says area equals length times width. 15 times 10 gives you 150 feet squared as your solution for number 14. Number 15. A scale drawing of a circular window has a diameter of 5 inches. If it was talking about halfway across, that would be the radius, okay? If it was talking about all the way around the outside, that would be the circumference. But right here, they're telling us the diameter is 5 inches. Okay? And the scale factor is 1 inch is equal to 6 feet. So what's the actual diameter of the window? So the real window is going to be obviously bigger. And if I cut this up into little fifth sections, 1, 2, 3, 4, 5. Okay. Pretend those are all equally divided. And we're saying, hey, from here to here is 1 inch. But in real life, that's 6 feet. Here's 6 feet right here. From here to here is 6 feet. Here to here is 6 feet. Here to here is 6 feet. 6 plus 6 plus 6 plus 6, or 6 times 5 gives me 30 feet. Okay? So our scale factor was 6, so 5 times 6 equals 30. So that diameter is 30 feet. Okay? It didn't ask for an area or anything, it just asked for the diameter of the real life window. Number 16 says, here is a scale drawing of a toy tree that is 3 inches tall. So this tree, its height is 3 inches. If the scale factor is 1 inch equals 3.5 feet, how tall is the actual tree? Okay, so there I've divided this up into 3 inches, 1 inch, 2 inches, 3 inches. Pretend that it's evenly distributed. But anyway, they're saying, hey, 1 inch right here in real life, on the real life tree, that's actually 3 5/10 feet. And then this little section right there is 3 5/10 feet. I'm not labeling, sorry. So the actual tree, I'd have to go 3.5 feet plus 3.5 feet plus 3.5 feet to get 10.5 feet. Or a faster way to do this whole entire problem is you just take your 3 inches, multiply it by that scale factor of 3.5, and you would get 10 1/2 feet. Okay, that's how tall it is, okay? Or you could put 10.5. Number 17, here's a scale drawing of a model car that is 4.5 inches long. The scale factor is 1 inch is equal to 2 feet. How long is the actual car? So you can sit here and divide this up in little sections, or you can just multiply by the scale factor like we did in the previous problem. 4.5 inches times that 2 scale factor, and you would get 9 feet in real life, okay? 18, here's a scale drawing of a baby doll that is 9 inches tall. If the scale factor is 1 inch is equal to 2.5 feet, how tall is the actual baby? So this is really crazy. The actual baby is very tall, because when I look at this, I can divide this up into 9 little segments and then put each one as 2.5 feet for each one of the little segments, or, you know, like what we did in the previous problems, just go 9 inches times that scale factor of 2.5 feet. 9 times 2.5 is 22 5/10 feet. Now, I don't know anybody that tall. Number 19, find the area of the compound shape. So you see this compound shape right here is composed of a rectangle and a semicircle, okay? So when I'm looking at this problem, I know that we need to divide it up and find the areas of each one of each of the sections, and then add them together to find the total area of this compound shape. So from here to here, it's 30 millimeters, and from here it's 20 millimeters. Since it's a rectangle, I need to go length times width to find that area of that little section there. So length times width, because that's a rectangle. And now, you know, I don't have to put the multiply sign there, right? Because when you have two variables together, that means multiply. Anyhow, 20 times 30, or 30 times 20, is equal to 600 millimeters squared. So this area right here is 600 millimeters squared. Okay, we're not done because we gotta find the total area. And we have this semicircle right there. And it doesn't look like at first there's much information, but there's enough information for you to figure that out. Because the distance from here to here is 20 millimeters, okay? So that means the radius from here to here is half of 20, which is 10 millimeters. Now, to find the area of a semicircle, well, first off, a full circle is pi times radius squared, right? But it's only half of a circle, so you're going to divide it by 2. I wrote this here as pi times the radius to the second power divided by 2. And that goes down to 100 is this value right here, 10 to the second power is 10 times 10, which is 100. So you're 100 pi divided by 2. And when I go 100 pi divided by 2, I get, well, hold on. 100 divided by 2 is 50, so it's really 50 times pi. So 50 times pi, and it doesn't specify whether to use 3.14 or the pi button, so I guess it doesn't really matter. Okay, so I got that area is this. I'm going to round it to just the nearest hundredth, so 157.08 millimeters squared. Okay, we're not done. We need to add, that's millimeters, them together. Okay, that should be the area of the compound shape. Approximately 757 8/100 millimeters squared for this area of this compound shape. Number 20 says to find the area of the compound shape. And this compound shape looks like it's just composed of a bunch of rectangles and maybe a square, okay? I'm going to go ahead and break it up right now. Okay, so let's go ahead and find the dimensions of this. So if I'm just referring to this right here, see it's 4 centimeters by 8 centimeters. That's a rectangle. Area of a rectangle is length times width. So I just need to go 4 times 8, and that is equal to 32 centimeters squared. Okay, I'm going to circle that because I know later on at the end I got to add it all together. This one right here, it's 4 centimeters by, well, same thing, 8 centimeters. So similar thing, length times width. 4 times 8 gives me 32 centimeters squared, okay? So far, we've got these two sections down. Now we just need this one right here, okay? And it's a different color. I know from here to here is 4 centimeters, but what about from here to here? Well, we got to kind of use some brain power here. This distance from here to here is 4 centimeters, so that means from here to here is 4 centimeters, right? We need to know from here to here. Well, if this whole entire length from here to here was 8 centimeters, and from here to here is 4, so that leaves the remainder of 4 centimeters right here. So that means this from here to here is 4 centimeters. Okay? Remember, from here to here is 8 centimeters, but from here to here is 4 centimeters. So here is 4. Therefore, this has to be 4, simply because 4 plus 4 is 8 centimeters, giving us a grand total of that. So the area of this square, because I know it's a square now, you gotta go length times width, so 4 times 4, that's 16 centimeters squared. Okay, we're going to add these three together to get the total area of this compound shape. And it is 32 plus 16 centimeters squared is equal to 80 centimeters squared is the total area of this compound shape. Okay, that's the answer, not any of the other ones. Okay, you got to add them all together to get the area of this compound shape. All right, the next one is problem number 21, and the area of this compound shape. This compound shape looks like it's composed of, well, you could break it up like this, and then like that, but that just makes it complicated. So I think the easiest thing when I first look at it is just to make it a rectangle and a triangle, okay? So the area of a rectangle, again, is length times width. So this right here is 5 centimeters, this right here is 8 centimeters, so 8 times, what, 5 centimeters? That gives us 40 centimeters squared, okay? Now let's go ahead and tackle this area of this triangle. Area of a triangle is 1/2 base times height, or 1/2 length times width, same thing. So, well, right here we have 5 centimeters, so that's the height. 1/2 that base times the height of 5 centimeters. We gotta find what that base is, though. And the base of this triangle is the distance from here to here, okay? Well, if this whole length from here to here is 8 centimeters, from there to there is 2 centimeters, from there to there is 1 centimeter, how many more do we have to get to make this a length of from here to here of being 8 centimeters? Okay, so 8, 7, 6 leaves me 6, minus 1 leaves me only 5 centimeters. Okay, so now I have enough information to go ahead and figure out the rest of the area of this triangle, or so I can figure out the rest of the area of this compound shape. So 1/2 base times height. Half of 5 is 2.5. 2.5 times 5 is 12 5/10 for the area of this triangle. Centimeters squared. Okay, that's not our answers. We just got to add these two together, okay? When I add 40 centimeters squared plus 12.5 centimeters squared, I get 52.5 centimeters squared. And that is the area of the entire compound shape. Okay, this problem wants us to find the volume, and looking at it, it's a rectangular prism. So just to remind you how to find the volume of a rectangular prism, all you gotta do is you just find the area of this face right here. You know, of any prism, you find the area of the face, multiply it by this right here, by h, okay? And that's what we're gonna do. So let's go ahead and find the area of this face right here. It's 3 by, well, from here to here, it's 5 centimeters. So I'm gonna do area of the face times h is going to give me the volume of this shape, of any prism actually. So the area of the face, what was it? 3 times 5 is 15, times h is 4. 15 times 4 gives me 60 centimeters cubed, okay? Volume is going to tell you how many little three-dimensional cubes fit inside of that three-dimensional figure. The next problem. Oh, look, it's another rectangular prism. Again, you got to find the volume. With any prism, you can find the area of the face and then multiply it by h. So, see how we chose this face right here? I'm going to choose this face right here. Find the area of the face, multiply it by h. Okay? Same thing as we did on the previous problem. Anytime it's a prism, you find the area of the face, multiply it by h, and that's going to give you the volume of that prism. Area of the face. So from here to here it's 9 inches because this from here to here is 9 inches. 9 times 10, 9 times 10 is 90. So that's 90 multiplied by h. Oh, sorry, h is this, 3, and that gives me 270 inches cubed. Okay, 24. It's, oh, this one's a cube because I can tell by the dimensions. So cube is a prism. Anytime you have a prism, you just take the area of a face, multiply it by h. Let's go ahead and take the area of this face right here, multiply it by h, okay? So it's 5 by 5, 5 times 5, that's 25, times h is 5. 25 times 5 is 125 inches cubed for the volume of this cube. Next problem. What is the circumference and area of the circle? So I'm going to draw the circumference in red and the area in a different color. So circumference is a distance all the way around. So you want to know that distance right there, okay? And circumference, its formula is 2 times pi times the radius. That gives you the circumference. So I'm going to keep the 2, I'm going to keep the pi, and I got to find the radius. The radius, oh, it's right here, 2.5. And that's going to give me the circumference. So go ahead and, you can multiply in any order. I'm going to go 2 times 2.5, which is 5. So I have 5 pi is equal to the circumference. That's the most exact answer, okay? Now the directions aren't very clear if they want you to keep it in terms of pi, which would be this, or if they want you to use 3.14 for that to substitute it in, or if they want you to use the pi button on your calculator, or if they want you to use the fraction 22/7. Since it doesn't specify, I can keep it like this, but I want you to, let's go ahead and just use the pi button on our calculator. 5 times pi. Okay, and we round to near hundredth, so 15.71 approximately is approximate circumference, but this right here is the actual answer, perfect, like most exact answer, okay? I'm sure this one's acceptable simply because the directions didn't specify. Okay, now it's asking for the area of the circle, and I'll do all those in purple. Area of any circle is pi times the radius squared. That's going to give you the area of a circle, a full circle. So pi times, well, this is the radius, 2.5. And we got to square that, which means go 2.5 times 2.5, okay? It's different than multiplying it by 2. So I got to go 2.5 times 2.5, or if you have this button on your calculator, see this little X squared right there? Same thing, okay? Or you can go 2.5 times 2.5, same thing, 6 and 25 hundredths. So it's pi times 6 and 25 hundredths would equal the area of the circle. And the most exact, precise answer would be 6.25 pi is the area. But let's go ahead and use the pi button on your calculator. 6 and 25 hundredths times pi on your calculator equals, we're going to the nearest hundredth, 19.63. That's approximate. Is the area of circle. And area is always labeled in units squared. It's centimeters squared, okay? The next problem. Another circle. What's the circumference and area of the circle? So I'll do the circumference in red. Remember, circumference is the distance all the way around. So circumference is equal to 2 times pi times the radius is the circumference of a circle. And I got to go 2 pi, keep those consistent. Now the radius. So from here to here is 18 inches. That's the diameter. So radius would be 9 inches. Don't get fooled, okay? So I can go 2 times 9, which is 18 times pi. 18 pi is the most precise circumference for this, okay? Well, I should label it inches, sorry. But let's go ahead and use the pi button on our calculator and go 18 times pi, and 18 times pi, and you should get 56 and 55 hundredths inches, okay? For the circumference. Now let's go ahead and go with the area, which tells you how many squares are in there. So area is equal to area of a full circle, pi times radius squared, okay? Pi. Now the radius again is 9, but you're going to square it this time, okay? Over here you just multiplied it by 2. This one you got to square it. So 9 to the second power is 81 times pi. That's going to give me the area. That's the most precise answer. So if the directions say keep it in terms of pi, that's it, you're done, okay? But I want you to go ahead and just use the pi button on your calculator. Go 81 times pi on your calculator, and then you'd get 254 and 47 hundredths inches squared, okay, for the area of the circle. And that's an approximate because we had to round. This one's exact. Okay, the next problem. What is the circumference and area of the circle? Again, for the circumference, I'll do it in red. The area, I'll have it in purple. Circumference is the distance all the way around, okay? And it looks like they give us the radius right here, so that's nice of them. So 2 times pi times the radius gives us the circumference. 2 times pi, keep it the same, and then radius is times 5. Give us the circumference. So 2 times 5 is 10. 10 pi, that's the exact circumference of this circle right here, okay? And I need to label it meters. All right, now for the area, oh, hold on. 10 times pi is going to be approximately, using the pi button on my calculator, 31.42 meters is the circumference, okay? All right, now to the area of a full circle is pi times radius squared. So we got pi times the radius of 5. We got to square that 5. 5 times 5 is 25. So area is equal to 25 pi to be exact, okay? But using pi button on a calculator, we get about 78.54 meters squared.